Plutonium-244 is an isotope of plutonium that has a half-life of 80 million years. This is longer than any of the other isotopes of plutonium and longer than any other actinide isotope except for the three naturally abundant ones: uranium-235, uranium-238, and thorium-232. Accurate measurements, beginning in the early 1970s, have detected primordial plutonium-244, making it the shortest-lived primordial nuclide. The amount of 244 Pu in the pre-solar nebula was estimated as 0.008 of amount of 238 U. As the age of the Earth is about 57 half-lives of 244 Pu, the amount of plutonium-244 left should be very small. Hoffman et al. Estimated its content in the rare earth mineral bastnäsite as a C244 equals 1.0 times 10⁻18 grams per gram, which corresponded to the content in the earth crust as low as 3 times 10⁻25 grams per gram. Since plutonium-244 cannot be easily produced by natural neutron capture in the low neutron activity environment of uranium ores, its presence cannot plausibly be explained by any other means than creation by our process nucleosynthesis in supernovae. Plutonium-244 is thus the shortest-lived and heaviest primordial isotope yet detected or theoretically predicted. However, the detection of primordial 244 Pu in 1971 is not confirmed by recent, more sensitive measurements using the method of accelerator mass spectrometry. In this study, no traces of plutonium-244 in the samples of bastnäsite were observed, so only an upper limit on the 244 Pu content was obtained. C244 less than 0.15 times 10⁻18 grams per gram, which is 370 atoms per gram of the sample, at least 7 times lower than the abundance measured by Hoffman et al. Unlike plutonium-238, plutonium-239, plutonium-240, plutonium-241, and plutonium-242, plutonium-244 is not produced in quantity by the nuclear fuel cycle, because further neutron capture on plutonium-242 produces plutonium-243, which has a short half-life and quickly beta-decays to americium-243 before having much opportunity to further capture neutrons in any but very high neutron flux environments. However, a nuclear weapon explosion can produce some plutonium-244 by rapid successive neutron capture.